The question says we are having 4 dice, D1, D2, D3 and D4, and we are supposed to find the probability that on D4 we are getting a number which is obtained either on D1 or D2 on D3, right? And first method is we can assume we can get any number of D4, right? Any number say X, right? According to the question, on D1, D2, D3 we should get same number X at least on one of the dice, right? And if we are doing it with the help of say bijection rule, that means 1 minus the unfavorable probability, that means on D1, D2, D3 we should not get the same number X. Now whatever number we are getting on X, the probability that same number is not obtained on D1, which is not obtained, the probability that the same number is not obtained on D1 is 5 by 6, because leaving X we are having 5 options. Similarly, the probability that the same number is not obtained on D2 is 5 by 6. So the required probability can be given as 1 minus the probability that none of the number obtained on D1, D2, D3 is same as that on D4. So the probability will come out to be 1 minus 5 by 6 into 5 by 6 into 5 by 6. 1 is with respect to D1, then D2, then D3. This is equals to 1 minus 125 upon 216. That will come out to be 91 upon 216. This is the required probability and this is the answer. In second method, what we can do, either D1, D2, D3, right, are having all equal, that is all same, or two of the number will be same and one would be different, or all three would be different, right? Now if all three number are same, then we are solving the question with the help of PNC, that is permutation and combination. The number of ways in which I can get all three same number will be 6C1. If two numbers are different, two numbers are same and one is different, then out of 6, what two numbers we are using over here and over here could be given as 6C2 into, first of all, 3C1. This gives me the number which are different, say 1 and 5, right? After selecting 1 and 5, I can repeat 1, 1, 5, or I can do 1, 5, 5, right? That would give me 2. This 3C1 explains, say this different number 5 is obtained either on D3 or on D2 or on D1, right? Now this ensures that I have got two different numbers on these three dice. Now D4 is supposed to have the same number as obtained on one of these three dice. So again D4 is having two options. Either this 1 is obtained on D4 or this 5 is obtained on D4, right? If all three are different, then which 3? That would give me 6C3 into 3 factorial. Which number on which dice? Say 63, I'm getting 1, 2, 5. Say one of the number is 1, second number is 2, another number is 5. Then 1 is obtained on which one of these three? Either on D1 or D2 on D3, or 2 is obtained on one of these three dice. Then which of the dice? That is taken care by 3 factorial into, now D4 is supposed to have one of these three numbers, so D4 can have either 5 or 2 or 1. So D4 is having 3 options. So again the required probability will be equals to 6C1 plus 6C2 into 3C1 into 2 into 2 plus 6C3 into 3 factorial into 3 whole divided by On 4 dice, total number of ways I can have these many, right? That will give me 6 plus this 6c2 will be 6 into 5 by 2 into 3 into 2 into 2 plus 63 is 654 divide by 3 factorial into 3 factorial into 3 and whole divided by 6 raised to power 4. I can cancel out 1 6 1 6 1 6 1 6. This will give me 3. Then again this 2 and this 2 can be cancelled. Similarly this 3 factorial and 3 factorial can be cancelled. So what I'm left with over here 1. So required probability will be 1 plus the second term from here. It will be 5 into 3 into 2, that is 30 plus one more number. I'm overhang 5 into 2, 5 into 4 is 20 into 3 is 60 divided by 6 cube. So plus 60 whole divided by 6 cube. So this is 90 plus 1 is 91 divided by 6 cube is 216. So this is my answer, the second way of getting the answer, right?